Your brain is doing exactly what it was designed to do. The problem? It was designed for a world that no longer exists, and modern food is exploiting every ancient survival instinct you have. For roughly 300,000 years, humans lived in environments where food was scarce, seasonal, and required serious effort to obtain. If you found ripe fruit or killed an animal, you ate as much as you could, because you didn't know when the next meal was coming. Natural selection rewarded the people who craved energy-dense foods, stored fat efficiently, and remembered exactly where to find food again. That's the biology you inherited. But here's the catch. Your environment changed faster than your genes ever could. In the last 100 years, and especially the last 50, food became abundant, cheap, and available 24/7 with almost zero effort. The systems that kept your ancestors alive in a world of scarcity are now pushing you toward constant overconsumption in a world of endless access. And it's not because you lack discipline, it's because your brain is still running software written for a problem that no longer exists. Today we're breaking down exactly how modern food hijacks your brain and why understanding that changes everything. Let's start with the basics. Your body has two main systems that regulate eating, and they're designed to work together. But modern food throws both of them off balance. The first system is homeostatic regulation, your body's way of monitoring energy needs and telling you when to eat or stop. This system runs mostly on autopilot. When your stomach is empty, it releases a hormone called ghrelin, which makes you feel hungry. When you've eaten enough, your gut and fat cells release signals like leptin that tell your brain, "We're good, stop eating." The key player here is a brain region called the hypothalamus. It's constantly tracking your energy reserves and adjusting your appetite to match. When things are working smoothly, you eat when you need calories and stop when you don't. But here's where it gets complicated. In people with chronic obesity, leptin signaling often becomes less effective. The brain stops hearing the message that the body has enough stored energy, so hunger never fully shuts off. Scientists are still figuring out why this happens. Inflammation, genetics, and diet composition all seem to play a role, but the point is, it's not a character flaw. It's a biological malfunction. Now, if that were the only system regulating eating, things would be simpler. But there's a second system, and this one doesn't care about calories at all. The second system is reward and motivation, and it's driven by dopamine. This system's job isn't to track energy, it's to learn what feels good and motivate you to seek it again. Here's how it works. When you eat something high in sugar, fat, or salt, things that were incredibly rare and valuable to your ancestors, your brain releases dopamine. That creates what scientists call a prediction error, basically a learning signal that says, "Remember this, seek this again." Over time, your brain starts associating certain cues, sights, smells, locations, emotions, even times of day with eating. Eventually, just seeing a bag of chips or walking past a bakery can trigger dopamine release before you even eat. Your brain is already preparing you to seek that food, even if you're not hungry. This isn't unique to food. It's how your brain learns everything, which paths are safe, which people are trustworthy, which behaviors lead to good outcomes. But when it comes to food, especially modern food, this system gets turbocharged. And here's the twist. Dopamine doesn't actually create pleasure. It creates wanting. The actual enjoyment you feel while eating, the liking, comes from a different system involving opioids and endocannabinoids in your brain. This distinction matters because wanting and liking can come apart. You can intensely crave a food, think about it constantly, feel compelled to eat it, and then when you actually do, it doesn't bring much pleasure. But the craving doesn't go away. You keep eating, chasing a satisfaction that never quite arrives. This is one of the most important insights from neuroscience, and it explains why people often feel trapped in patterns they don't even enjoy. So what makes modern food so effective at hijacking these systems? The term ultra-processed or hyper-palatable gets thrown around a lot, but the key is understanding what these foods actually do mechanistically. First, they're energy dense. Lots of calories packed into a small volume, usually because of added fats and sugars and very little water or fiber. That makes it easy to consume a lot of energy quickly. Second, they have a rapid eating rate. Soft textures and low fiber mean you can chew and swallow fast, which outpaces your satiety signals. Those signals take about 15 to 20 minutes to fully register, so by the time your brain catches up, you've already eaten way more than you needed. Third, they're engineered combinations, specific ratios of fat, sugar, and salt that maximize reward signals. These combinations almost never occur in nature, but they're everywhere in processed foods because they've been optimized through decades of food science research. Fourth, they're low in protein and fiber, the two nutrients that increase satiety the most. When you strip those out, foods become less filling per calorie. And fifth, they're convenient and heavily cued, packaged, pre-portioned, advertised constantly, and designed to be eaten anywhere, in the car, at your desk, on the couch. Every context becomes a cue, which strengthens the habit. None of this is moral judgment, it's just biology. These properties reliably increase how much people eat in controlled studies. It's not about willpower, it's about how the food interacts with your brain. Which brings us to the willpower myth. Blaming overconsumption purely on lack of self-control ignores a huge amount of evidence. Sleep deprivation disrupts hunger hormones and weakens impulse control. Chronic stress raises cortisol, which increases appetite and impairs decision-making. Habits and environmental cues drive most eating behavior, not conscious choice. And people vary genetically in how sensitive their reward systems are, how strong their satiety signals are, and how efficiently they store or burn energy. Current estimates suggest genetics account for somewhere between 40 and 70% of the variance in body weight. That doesn't mean behavior doesn't matter. It absolutely does. But it does mean the playing field isn't level. Some people are fighting biology that makes certain behaviors significantly harder. Willpower is real, but it's a limited resource. Expecting it to carry the full load in an environment designed to overwhelm it isn't realistic. It's like asking someone to hold their breath indefinitely. Eventually, biology wins. That's where new tools come in. Drugs like semaglutide and tirzepatide, often called GLP-1 agonists, work by mimicking a natural gut hormone that signals satiety. Normally, that hormone only lasts a few minutes. These drugs make it last for days, effectively turning up the volume on your body's "I'm full" signal. The result? People feel satisfied sooner, think about food less, and find it easier to eat smaller amounts without the constant mental battle. Clinical trials show average weight loss of 10 to 20%, which is significant. This isn't medical advice, and these drugs aren't right for everyone, but conceptually, they matter because they demonstrate something important. When you change the biology, the behavior changes. It's not about willpower, it's about leveling the playing field. So where does that leave us? The point of understanding all this isn't to remove personal responsibility or excuse behavior. It's to replace shame and confusion with clarity. Your brain and body are doing what they were designed to do. The mismatch isn't your fault, but navigating it effectively does require understanding how the system works. If you know why certain foods are hard to resist, you can make more informed choices about which ones to keep around. If you understand how cues drive behavior, you can change your environment instead of relying purely on willpower. If you recognize that sleep, stress, and habits matter as much as food choices, you can address the whole system instead of just one piece. You're not broken. You're just trying to survive in a world your biology wasn't built for. And once you understand that, you can stop fighting yourself and start working with the tools you actually have. If this shifted how you think about food in your brain, leave a comment. And if you want more videos that break down complex science without the shame or oversimplification, hit subscribe, and I'll see you in the next one.